Hi, in this video we're going to talk about how to build a circuit on the active HDL program. As always, we're going to use our lab manual to guide us through the circuit that we're going to build. Let's say we will build this circuit, which is a full adder circuit, which is consists of two outputs, summation and Cout, abbreviation for carry output, two inputs, A and B, and the third input is a Cin or carry in. Next, we're gonna build the top level design, which what we are seeing here, also found in the lab manual. Keep in mind that the circuit that we just built, it's represented in this rectangular box as a full adder, and as we can see, it still has the Cin input, A, B, and the outputs are Cout and so on. What we did is we just creating an output circuit in order to make this inner circuit, the full adder, be able to work with the microcontroller device that we're gonna use, which is the basis 2. All what we need to do is we're gonna follow the steps that is well detailed and explained in the lab manual. Here in part H, it's give you more instruction about how to plug the board, and then search for this file in your folder, and then click on the program, and then finally you should receive a message here of the completion. I opened the program using the instructions, and then I will go to the device. There is a switch, main switch, on off. The LED light, the red LED light represents the device is on. Next, I'm gonna click on browse on the FPGA side and go into the path and select the file that I need. Keep in mind that in this path we found in the lab manual BKDean, because this is when Dr. Dean made the program. So in your case, you will find your username, and then I click program. And then as you can see, it's saying here program successfully. Here, I go to the next page, and then I try to fill this table. As you can see here, there is 3 inputs, Cin, A, and B, and also we have 2 outputs, which is the summation, and the Cout, which is the carry out. These are coming from the circuit, or representing the circuit that we already seen in the beginning, which is this one. So already you see here we have 3 inputs, Cin, A, and B, and the 2 outputs, sum and Cout. So let's talk about the top level design. From the input side, we have SW10, and it's connected to red thick line. The red thick line represents a bus. A bus is a combination of more than one wire, or just a single wire, or a group of wires. In this case, this bus is continued of just 2 wires. How we would know? From the 10. The 10, when we want to separate this array, we're gonna start by SW1, and then we go down until we reach the last number, which is SW0. If we have SW30, that means we have 4 inputs, or 4 wires in that bus, which are represented by SW3, SW2, SW1, SW0, and so on. This bus down here, which is the BTN00, represented by just single wire inside that bus, as we can see here, and it's connected through the blue line. Oh, I forget to mention that the blue thinner lines represent just a single wires. Important thing, which is when we have a wire connected into a bus, it has to have a unique name. That unique name currently is LED1 and LED0. And we also have more complicated things that we don't need to mention, why we choose these names. So please just name them as you can see here in the circuit, or in the lab manual. Now keep in mind that the inner circuit, which is the Cout in the table we can found, is represented by LED 1. So that's why when we go to the C out, we're gonna name it LED 1. And same thing for the sum, we're gonna name it LED 0. Same thing for the C in, we're gonna name it BTN 0. And for A and B. I forget to mention also, it's very simple to name a wire. You just double click on the wire, and then you would be able to name it. Give it a name, and then click OK, as we can see. Now, let's go to the table. For the C out, we're gonna write LED 1. How we would know that? We know this from the top level design. We match the C out with the LED 1. Now, sum, LED 0. Next is B. Look at the top level design and then name it. Or you could use it from the lab manual. And after we complete all of them, we're gonna see how we could use them. Now, with those being done and completed, we're gonna go into the board or the microcontroller that we're gonna use. As you can see here, the BTN 0 here, the push button. When we press it, it's on. This is LED 0, and currently they are off. This is LED 1. The LEDs are off currently. When they are on, they give us a red signal. As you can see here, we have switch 0 and the switch 1, SW0 and SW1. For the push button, switch 0 and switch 1, they are on the inputs. LED 0 and LED 1 represent the outputs. Currently, the switch is switch 0 now is on because it's next to the LED. So if we push them forward or to the top of the board, they are on. If they are on the down position, they are off. So currently, I'm gonna switch 0 to the off position. Here we go, and here we go. This is the on position, and this is not because of the LED. Let me show you. This is on. This is on, also switch 1, and this is switch 1 and 0 off. For the push button, in order to turn it on, we need to press it and keep pressing on it. When we remove our hand, it's gonna go back off. Let's take an example. If we want to represent this fifth row, so switch 0, 1, switch 1 is 0, button 0 represent 1. We come here, we turn switch 1 into the on position. As you can see, it's on the on position. Switch 0 is on the down position, which is the off. And then the push button, we need to keep pressing on it in order to let it be a 1, 0, 1. Then we take the reading from LED 1 represent 1, LED 0 hence it's off represent 0. And that way we're gonna fill the table. Now you can complete all of the table. And that's it for our video. Thank you so much. That's the end of this video. I hope that you enjoy it.